Okay, here's our video on the volume of cones and pyramids. And we'll start with pyramids. So let's draw a pyramid here. Let's bring it up here. I'll draw a rectangular pyramid, or a square pyramid. So it has a base that's a rectangle. So the formula, put it over here, volume equals 1/3 base times height. Now you can also write this, bring that up, base times height divided by 3. So we have two formulas here we can use. Whatever one you prefer, you can use. So let's do an example. Let's go back to the pyramid here. Let's say on one side it was 6, the other side is 5. So we know it's a rectangle, not a square. And now the only thing we're missing is the height. So usually you'll see this dotted line for height, and we'll just say 4. Okay, so let's look back here. We're going to do the B, the capital B. The capital B is what the area of the base is. So the base, the area of the bottom, the base, is 6 times 5, so that's 30. The area is 30 units squared. Since we don't have any measurements here, we'll just use units. So that's what the capital B means. So now we're going to say 1/3 base times height. We already know that the base is 30, the height is 4. So whatever formula you used, if we use this one, we can say 30 times 4, which is 120. And again, we have that 3 there. We have to divide it by 3. Okay, so it gives us our answer here. We'll write it over here. The volume is 120 divided by 3, which will give us 40 units cubed. Very important to put the cubed when we're dealing with volume. So again, let's review that. The formula was the base, the capital B base, times the height, and the base of the pyramid was 6 times 5. 6 times 5 is 30. We times it by the height of 4. We got 120, and we divided it by 3, because that's what the formula said. And again, the area, the volume that is, the volume is 40 units cubed. Okay, let's look at another one. And again, when we're dealing with pyramids, we can have a square or a rectangular pyramid. We can also have a hexagonal base. We can have an octagonal base. The ones you probably see more often is either a rectangular base, a square base, or a triangular base. So let's make one with a triangular base. So we'll have something like this, and we'll make one close to it. So now the base is a triangle. Almost a triangle. Let's fix that. There we go. A little messy. So now it's very important here. Again, we'll just write the formula here. The volume is base times height divided by 3. But here we have to be careful because the base is a triangle. Very important to remember. The base is a triangle. So we need to find the area of that triangle base before we do anything else. So let's say we have, let's put a 3 there and a 7 there. Just any numbers we're throwing in. And we'll just say the height, we'll say the height is 9. So again, that's a 3. Fix that. That's a 3. Okay, actually let's change these numbers, make it a little easier. Make that a 10, make that a 4. Okay, that's a little easier. So again, we have to find the area of the triangle, because the triangle is the base. And remember, the area of a triangle, if you remember the area of a triangle, is base times height divided by 2. Right? So let's look at this. 4 times 3 is 12, so 12 divided by 2 gives us 6. So that's what this capital B is now. That's the base. It's 6. Because the area is 6 units squared. Right? So let's erase that now. We know it's 6. So the volume is now 6 times the height, remember that, over 3. So now 6 times 10 is 60. So we'll bring it over here. The volume is going to be 60, because 6 times 10, the height is 60, over 3. Bring this up, and we have a volume that's going to be 20 units cubed. Don't forget to put the cubed sign when we do volume. Okay, so that was, we did one with a rectangular base, one with a triangular base. Let's do a tricky one now. All right. We'll have one with a rectangular base. I'll just draw a pyramid again. It has a rectangular base. And let's say we'll bring those numbers I put before. 3, 7, and again the height is, well, let's say we don't know the height. That's our challenge. We don't know the height, but we know the volume. Okay, so let's say that the volume is 63. So we have the volume, and we're just missing the height. So base times height divided by 3. That's the formula. V equals base times height divided by 3. V per volume. We have the volume of 63. We're just missing the height. How do you think you can solve something like this? Okay, so well, we do know the base. Remember, 7 times 3 is 21. So we can just get rid of the B, and now it's 21H. Right? So we want to isolate the H. So I'll bring the 3 up. Remember the old trick, you can multiply up or divide down, so we'll multiply this whole thing up. Okay, so I'll just bring this up a little bit. So 63 times 3 is 189. So we have 189 equals 21H. Now perform a little algebra here. We'll just divide out the 21 to isolate the H. Whatever you do to one side, you do to the other side. Okay? And 189 divided by 21 gives us H being 9. Okay, so that's how we found H. Now let's look at cones. This volume, we did volume, and now let's do cones. So let's make a little cone here. Here's our cone, ice cream cone, whatever it is. And the formula, the volume for a cone is 1/3 pi, we have to use the symbol pi, r squared h. Now you can also, there's another way of doing it, you can do pi r squared h over 3. Whatever one you want. We have options. Okay, so let's look at a cone. Let's say that we had a dotted line showing the radius, and let's say the radius was 5. And we have h, let's say the height is 12. That's all we need to find the volume of this cone. Now when you have questions like this, they might ask you to solve in terms of pi. That means we're not going to actually plug in pi on the calculator. We're just going to leave it as pi. I'll explain that in a minute. Let's just solve it using pi. Okay? So again, we're looking for the volume, and we said it's 1/3 pi r squared h. So we can put this all over 3. And we have pi, which is 5. We have the radius, which is 5. So we can say 5 squared is 25. So there's our 25. We'll leave our pi in here for a minute. And the height is 12. So that's the first part. Okay, so 25 times 12 is 300. So we have volume now is 300 pi divided by 3. That's our next step. 25 times 12 is 300. Now, if we were leaving this in terms of pi, we wouldn't solve pi, we'd just leave pi there. But in this case, we're going to solve for pi. You can press pi in the calculator. If they told you to estimate pi, you can do 3.14. But you can just press in the symbol pi on the calculator. So if we did that, we'll bring this up now. The volume is going to be 300 times pi on the calculator, which is going to give us basically 314.15 continuous, right? It's It's about that. That'll be our answer for the volume. So how did we get that answer? We did 300 times pi, so the volume is going to be about 942.47, and that 7 keeps continuing, divided by 3. And if we divide that by 3, we would get this answer. That would be our volume. Let's do another cone question. Make another cone. That. Let's say that we have diameter of 16. So I gave you that, a diameter of 16, and the let's say we were looking for the height. Let's say we're looking for the height. What will we do here? So let's make our formula again. The volume, again, is we're going to do pi r squared h. Remember, it's pi r squared h over 3. The only thing missing to solve this is you need the volume. You can't solve this without the volume. So let's say the volume, we'll just say the volume now, is 335.1. What else is missing? We're missing the radius. We know the diameter, right? So the diameter is this whole thing here. So I'm going to multiply up. We're going to do 335.1 times 3. And we're going to get 1005.3 equals pi r squared h. Right? So we move the 3 up. Now we have that. Now again, we said that the diameter was 16, so the radius is 8, and 8 squared is 64. So now we have our 64, and we're trying to find h. Now on the calculator, bring this up, on the calculator we're going to do 64 times pi. And that's going to give you roughly, so we'll write this down here. Place this over here. It's going to give you 201.0619, and it continues. So we'll just leave it like that for now. And then we have our h. So now we have our algebraic equation here. We're going to divide this out. Now the h won't be exactly what you're looking for because we're not putting the whole pi in our answer. But on your calculator you would do this. I'm just showing you some numbers here. If we divide that out, cross that out, h will be about 5. It's 4.999. Now if we put in the whole pi, if we did 64 times pi, got that answer, which is close to that, there's more numbers, we would see that h equals 5. So let's say that we're trying to find the volume of this cone. Let's make a better looking cone, actually. Here's our cone. Okay. And let's say that we're, and again, I'll put the formula over here. Volume is pi. I'm not sure. There's Alexa talking. R squared h over 3. And let's say that we have the radius. We'll put the radius over here. Let's say the radius is 2, and we know the height is 3. Okay, so our volume is now going to be, and we're going to do this not in terms of pi. We're going to do this in terms of pi, so we're not going to solve for pi. So our radius is 2, so 2 squared is 4, so we have 4 times the height of 3 times pi, and we're not going to touch pi, all divided by 3. Okay, and 4 times 3 is 12, so I'll erase this. And I will just say volume is 12 pi divided by 3, and 12 divided by 3 is 4. So the answer, in terms of pi, will be the volume is 4 pi. Units, don't forget to put units cubed. So this is, if it was in terms of pi, you won't solve for the pi. Okay, great job.